At TERMIS this year, we did a presentation on the industrialization of regenerative medicine. This presentation really stems from the development of methods to grow engineered tissues, particularly engineered arteries, that Humacyte has been undertaking now for nearly 17 years. What this talk really covered was the initial concepts that were developed in very much of a benchtop or a cottage industry setting that identified the key cues that we needed to provide to vascular cells to coax them into forming a new artery. We then gradually over time took these key cues that we had identified on the benchtop and then industrialized those. And by that, I mean, we developed methods to apply these same cues in a reliable way to cells, not just growing one vessel at a time, but growing 10 vessels at a time, or now even 200 vessels at a time. But really, some of the central ideas that are required to be successful in really industrializing a process that starts out on the benchtop is to identify the key parameters that are important for the cellular environment. That can be oxygen, glucose concentration, concentrations of growth factors, pressures, mechanical stretch. You know, there's a large number of factors that can be important for these types of studies. But then once those factors are identified, it's really critical to maintain those factors constant as you go from small scale to large scale. And really, in order to do that, Humacyte's approach has been to take our core process and to scale it out rather than scaling it up. So, for example, in pharmaceuticals, it's very common to make recombinant proteins in a batch method where a small vessel might be used to start, 10 liters, and then you might go to 1,000 liters, and then you might go to 10,000 liters. But inevitably, as you scale up that type of process, the oxygen, the pH, the shear stress, the mixing, there are many factors, physical factors that are important for the cells that can change just by virtue of the scaling up process. So Humacyte sought to avoid that confounder. And really, we chose to scale our process out, which meant that we took our individual bioreactor process and then we replicated that across many bioreactors within a single system.